Okay, hey Science 10. It's going to go through 5.1 here. So the first one says determine the length of each line segment. Rough sketch may aid your understanding. So what I'm going to do is draw a little sketch, just really rough. I just want to show you we got 2 points we're going to plot here, and we want to figure out how long it is. So the first point, I'm going to go 2, 7. So I go over to the right 2 and up 7. So I'm just kind of making this up. So it's around there. 2, 7. And then the next point's going to be 5 over and then up 7. So 5, 7. And this is the line, right? It's saying how long is that line? Well, if I look at the difference between the x values here, so the 5 and the 2, the difference between those is 3, right? There has to be 3 ticks to get from there to there. So that's how we're going to do these. All of these are either going to be like that, or they're going to be maybe straight up and down too, something like that. So, yeah. So I'll let you go ahead and do those ones. The only ones I think you might have a little bit of trouble on thinking about is this one. So E and F. I'll do E and then I'll let you do F on your own. So if you do E, I know it's letters, that's confusing sometimes, but if you think about it, we've got a P for our X value for the first one and a P for our X value for the second one. It's going to look similar actually to our first one because sorry, we got for our X value we have a P there and we have a P minus 4 for the X value there, and then for our Y value we have Q and Q. So that means this point, let's call this Q and that Q for like up and down, right? So the Y value on both of these, so Y up and down, right? This is our Y axis and our X axis. Yeah. It's still going to be a line like this. We know that because Q and Q are both our Y values, so they're both on the same level on the Y axis. But if we look at our X values, one is P, so let's call this one point A. So this will be P comma Q. And this point will be P minus 4. Oh, that was a bad way to write that. P minus 4 comma Q. Well, you can see that this point here, for as far as X is concerned, is P. And then this point is P minus 4. So this means this must be 4 this way. Right? It went back 4. So this line is still, I know this line is 4 long. I shouldn't draw more arrows out there to confuse you. But yeah, that line has to be 4 long, right? Because it's P minus 4. So I know the letters get a little confusing, but if you think about it, it's still not too bad. It's just like the first question. So I'm going to let you do F. It's similar. But yeah, I'll let you do that one. So if we move on down, it says a triangle has vertices at P. Yeah. Let's sketch a triangle on the grid. Determine the area of the triangle. One sec, I'll draw that. There we go. So it says determine the area of the triangle. So remember the area of a triangle is just equal to base times height divided by 2. So we've got a base, it goes from P till Q, and we got a height, just goes from this point up to the top, right? So I'll let you do that. And the only the way this is gonna, like, you're able to count these, right? So the base I can say is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I just want you to know though, that only works because our scale, our Cartesian grid, goes up by 1. So if this was 0, this is 1, 2, 3, 4, 5. And so I know it goes up by 5s. We couldn't just count these ticks. Let's say if our grid went up, like this was 10 here or something, right? Our grid went up by 10. We'd have to go by the same scale as they were using. So I just wanted to make sure you guys know that. But for this one, we can just kind of count the blocks all the way across that way, and then count the blocks going up as well to figure out our height. So I'll let you guys do that using areas equal to base times height divided by 2. These ones say use Pythagorean theorem to determine the lengths of the following line segments shown on the grid. So these lines, give each answer as a mixed radical in the simplest form. So let's do AB. So AB, if you make this into a triangle, so there to there, we can figure out how long this line is if we just use Pythagorean theorem. So I'm going to count the ticks here, but again, the only reason I can is because I know every one of these ticks goes up by 1, right? Because it goes to 5 on each side. So I can just count the ticks. Probably be the easiest way to do this one. So I'm going to count the bottom and say, okay, this tick is 1, 2, 3, 4, 5, 6, 7 on the bottom. This is 3 this way. So if I want to find out what my hypotenuse is, that's a squared plus b squared is equal to c squared. So that's going to be 7 squared plus 3 squared is equal to c squared. So 49, oh, it's glitching out. 49 plus 9 is equal to 58. So all I gotta do if I want to figure out what c is, I gotta take the square root of that. So square root of 58 is what I'm looking for. So square root of 58. And though it says give each answer as a mixed radical. So in this one actually can't be expressed any smaller than square root of 58. So we can just write it as square root of 58, or you can write it as square root 58. So it would be 7.6. Okay, I'll let you guys go ahead and do E and F too. So don't worry too much about the mixed radical thing. Just figure out what it is. Use Pythagorean theorem to find out what it is. Yeah. Oh, and this said to the nearest hundred, so that should have been 7.61, I guess. All right, and that's it for that one. So that's just a quick little one. So I'll see you guys in the next video.